Hey, it's Dr. J. 3.4 today, composition of functions. Let's get after it. So a composition means to compose two functions. Now the classic names for functions are f and g. Although there are lots of other names. There's h, there's p, basically any letter of the alphabet could be the name of a function. And we try to avoid things like O and X and Y and things that are already being used for other things. So we try to use special names for functions. I will try to keep it simple and just use F and G in this lecture. So to compose, the symbol for compose is an O, not a dot, because a dot would mean multiply. And that's not what we're doing today. So we are not multiplying the functions together. We're composing the functions. Composing, you typically need a variable. There can be other variables besides x. You can have y, you can have t. But again, to keep the introduction simple, I will use the traditional x variable as the input. And so a composition means to first find the value of g. So g goes first, and f goes last. So in other words, what you're doing, here's the abstract idea. You're taking an x, that's your input. You are plugging it in to become the output, g of x. But then the output becomes the input for f of x. So first, g takes the x value, produces an output. Then that output then becomes the input for the f function, and then the f function takes it the rest of the way. It's kind of like a relay race. It's like g runs the first half of the race, hands off the baton to f, and then f runs the rest of the way. And so this would be the final composition. We call that composing. We'll start off by doing it with a variable, and then we'll eventually expand this to numbers and actually plugging in values for f and g. So in all of these examples, I'm going to want you to simplify the result. I'll give you the two functions, and I'll ask you to compose them. So find the composition. Fit all that on the page. The most common composition is called the fog, F-O-G. So since this is example 1, we'll start with that. So again, fog means to take the formula for f and input g inside of it. So f is the outer function and g is the inner function. So you'll hear me say that a lot. When I'm composing, I like to refer to who's on the outside and who's on the inside. So on the outside, it's f. So here's what I recommend doing. Remove the variable and replace it with a big enough set of parentheses to hold g. Okay. Now, I think I made this clear in one of my previous lectures. G is just the name of the function. You could put the name of the function in there. Yeah. But as soon as you do that, you have to replace G with who G actually is, 4x squared plus 3x. So oftentimes I will skip this step because I know that ultimately the name of the function doesn't count, right? I mean, back when I used to go to work, you know, and I am at work right now on YouTube, but you know, when I actually had to get in my car and drive to work, I couldn't just send my name with me. I had to go. I had to actually be there and present. Right? So this is you. This is the actual function. This is just the name of the function. I couldn't just send my name to work, right? I mean, you know, Dr. Jordan's here, yeah, in name. Yeah. I guess I can do that now with the Zoom, right? And I'm sure some of you do that. You just log in and you press mute and you turn off your camera and you're there in name only, but you're not actually there. So this is what it means to actually be there. So plug it in. Don't forget the rest of the function. Plus 2. Okay, so this is your composition. Now you're going to simplify the result. This is a relatively simple one, so it'll be 20x squared plus 15x, and then don't forget the plus 2. Since we don't have a value for x, we don't have an input yet, that is the final answer. If I were to put an input, then we would get an actual numeric result. So that's fog. Well, if you can fog something, then you should be able to golf it as well. So let's do the composition GOF. GOF. So this time G is the outer function and F is the inner function. Make sure you put it in the right order. In terms of who goes first and who goes last, it's actually the inner function that goes first and the outer function that goes last. But when we write it, we often write the outer function first. So we're writing it first, but in terms of who actually gets up to bat, or if it's a race, who actually runs first, it's the inner one that's actually running first. So watch how I do this. Remove all the variables from the outer function. We'll start with the outer function. Make sure you make enough room to fit the other function. So don't do this. All right, you won't have enough room to fit a whole function inside of there. So open up. So it's as if one function is literally composing itself with the other function. Let me compose myself. Okay. So notice how I removed the variables. Leave them blank for a second, and then go ahead and plug in F into the function. Now, I said this last time, you can actually put the letter F in there, but you're going to find that immediately you have to get rid of the name and you have to show up in person. So F must actually be what it is. It is x plus 3. So again, I think after this example, I'll skip this step and I'll just jump right to this line here. Now you do have to calculate this carefully. Be careful. Keep the 3 out for a second. Multiply this. If you could do it in your head, that's great. Means you had a good experience in your last math class. So if you can jump right from here to here, that's great. Over here, make sure if this is a negative, you distribute it with the value. I'm distributing the 3. I'm running out of room here. Whenever I do this, I try to copy it down. Exactly where I left off here, so. Distribute the 3. 3x squared plus 18x plus 27. And then bring down the negative 4x and the negative 12. And combine like terms. 18 and negative 4. 27 and negative 12. That would be your final answer. All right, so those are the 2 most common forms of composition. One of them we call it the fog, the other one we call the Goff. I'll tell you right now, there's a way that you can always get this wrong. If you want to always get it wrong, I'm being facetious when I say that. I know you don't really want to always get it wrong, but I'm going to tell you right now how you can always get it wrong. If you distribute the 3, yeah, that will always be incorrect. Yeah. So if you go like this, 3x plus 9, and then try to square it, that will always be incorrect. That will never, ever, ever give you the right answer. Okay. There's another way you can always get this wrong. So the first way is distributing that 3. The other way would be to distribute the 2, the exponent. That will always be wrong. Yep. So if you want to get it correct, don't do either one of those things. Otherwise, you will just always be wasting your time and my time, and it's a futile endeavor. If you want to get it correct, do it the right way. It's x plus 3 times another x plus 3, so make sure you multiply that out correctly. If you can do it with mental math and get the right answer, that's great. If you need a little bit of, step-by-step procedure, that's also fine. As you move through this college level class, I hope you start to hybridize these two. Sometimes you're using mental math, sometimes you're writing it down, sometimes you're doing a combination of both. That's the real point of this course, is to get you to that level. All right, so there's your answer. It is very difficult to check your answer, right? So it's hard to take this and go backwards and try to figure it out. Checking your answer really amounts to just doing the problem carefully and being very careful with each step. That's how you're going to check. Okay, you can also do what's called self-composing. So you can do self-composing, that's called FOF, or GOG. Yeah, so FOF or GOG. I don't know how much you're wondering how important this variable here is. It's important in that it tells me that my answer will involve X. So that's what this means. So if that was a T, then that would tell me that my answer involved the letter T. If this was a Y, then my answer would involve the letter Y, or a P, or whatever letter. If this was a number, then that would tell me that my answer is going to be a number. So oftentimes when you're taking notes or when you're solving these things, your brain has a tendency, and by the way, I have a brain too that does this, and tries to eliminate things that it thinks it doesn't need, right? That's self-preservation. That's your mind trying to keep itself, free of any excess baggage. It tries to clear out things. This happens when you sleep, by the way. You forget 80% of what you learned that day because your mind is trying to clear out. It's like constantly cleaning out its garage. Okay, so that's not something you want to throw out. Keep that, you're going to need that. So FOF means to put F inside of itself. So this is only going to use this function F. Remove the X. So X becomes blank. And then put F inside of itself. And you can remove the parentheses now, and you're just going to get X plus 14. So this is F composed with F. GOG is going to be a little tougher. You can tell because it's got powers. Anytime you see exponents or powers, you better be prepared to work. I don't know if I left myself enough room here, so I might have to move away from this. Let's see. So GOG, again, start with G and compose it with itself. So remove the X. All right, so notice this looks just like G. It just doesn't have the variable. It has a blank set of parentheses. Leave it blank for a second. Now, sometimes we're in a hurry to just shove all the numbers and letters in there. Let's just get it done, Dr. J. I got somewhere to go, But just that 1 second will save you so much more time in the future. Spend it now so that you can save it later. Don't try to save time right now, because saving time right now ends up costing you more time later on down the road. And then now put this entire function inside of here with the variable X, because that's what it tells me to do. Okay. Now again, if you can do this with mental math, that's excellent. Be very, very impressed if you can do this mentally. So this is what it would be with mental math. All right. Oh, and then don't forget the rest of it, plus 6. Now this one doesn't have any external powers, so just distribute, so you get 6x squared plus 36x. And I'll finish that off later. Okay. My board's getting a little crooked here. Part A was really easy, so I'm going to go ahead and erase that. Part B here, this G function. So suppose you can't do mental math. If you want to show the work, you've got x squared plus 6x squared. And then 6 times x squared plus 6x. Again, I'm just going to show you how I got this. So this would be x squared plus 6x times x squared plus 6x. Do not just plop the 2 inside. That never works. Now here, you can go ahead and distribute this 6 because there's no external powers. So that's legal. In order to distribute, there cannot be any external powers, powers that are outside the parentheses. So that one's done. This one's going to take a little bit of work. You remember FOIL, x squared times x squared, that's x to the 4th. X squared times 6x, that's 6x cubed. Another x squared times 6x is another 6x cubed. And then finally, 6x times 6x is 36x squared. So that's how I got this part. I should put a cloud around it. That's my mental math cloud. Just for this part. These last two terms are the same, so just bring them down. You better bring them down or you'll forget about them. You know, sometimes you'll be so busy working over here that you completely forget what's going on over here. And then now combine like terms. That'll be 12x cubed. 36 and 6, that'll be 42x squared. And then this doesn't have any like terms or friends. So there's your final answer. Okay. So there you go. In a nutshell, that's 21 minutes of fogging and goffing and fuffing and gogging. Yeah. So those are the 4 different types of compositions. Next, we're going to see what happens when you put a value in. Okay. So this is fog. Let's just do that one first. We're going to go ahead and wait. We'll wait on the other one, the goff. So F parentheses G parentheses 0, sorry, I put an X, means fog of 0. So now we're actually plugging a number into the function. First, plug into G. So that's G of 0. Now, replace G of 0 with 5 because you now know that G of 0 is 5. That's that, baton is being passed. So G ran the first part of the race. It got all the way to 5. And then now 5 goes into F and F finishes the race. So plug it into F. 3 times 5 minus 1, 15 minus 1, and the final result is 14. Okay. The other way to do it, there is an alternative that says method. Sorry, it's very badly written. Is to do the whole problem with X. I'm going to do it rather quickly since I just did this a minute ago. So the alternative method is to keep the variable as X all the way down the road x, 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 until you have a completely simplified answer, and then you can plug in only one time. So if you do it my way, my original way, notice you have to plug in twice. First you plug it into G, and then you plug it into F, and then you get 14. So the alternate method is a little bit cleaner because you only have to plug in the number one time. So you just plug in 0, or whatever number is here. It might not always be 0. And then you get 14 minus 3 times 0 squared, which is clearly just 14, because 0 squared is 0. Sorry, I'm not sure if you could see that. I'll put it up here, 14. Check. So you're going to get exactly the same answer either way. I'm not going to advocate one way or another. Sometimes I do it the alternative method, and sometimes I do it the original, intended method, I guess you can call it. And again, here's what will never work. If you take the 0 and try to plug it into both, that never works. Yeah, that will never, ever work, because you're not plugging 0 into both. You're plugging 0 into G, and then you're plugging 5 into the other function. So plugging 0 into both functions would certainly not work. Okay, so let's do it the other way now. I said we're waiting on this one, so let's do Goff. Yeah, that's what this means. G parentheses F. Oh, and we're not using X, we're using 0. So first we're going to do F. So first plug 0 into F. Let's do that over here, mental math. So, you could do this all in your head. 3 times 0 minus 1 is negative 1. And then F of 0 is negative 1. So again, it's like F ran the race first. It got you all the way to negative 1. It's like, thanks, you left me in the negatives. Now I'm behind by 1. And now G runs the rest of the way. So G is 5 minus blank squared. Negative 1 goes in the blank. Be careful. I can't tell you. I even say this in my calculus advanced math classes. That looks like 2 negatives, but because of the square, you got to be careful. That's actually 3 negatives. It's a negative times another negative. So the final answer is 4. Yeah, negative, negative, negative is still negative. And then 5 minus 1 is 4. I'll leave it to you if you want to do the alternative method. I'll say DIY. You will still get 4. So I recommend trying that. In other words, do it with just X, and then when you're done, plug in 0, and you should get 4. If you decide that the alternative method is better for you, then you should do it that way. Yeah, I want you to do it the way that you feel comfortable with. Oh, and there goes my thing here. It's not that bad, but it is a little blurry. Sometimes if I threaten to shut it off, it'll go back. Come on. Come on. There we go. Still a little funky, but anyway. So this is FOF, F-O-F of -5. So this means take F of F and of -5. That's what it means. Ah, there it goes. Just in time. Where you been? We've been waiting for you. So you're basically double composing. It's as if you're running both, or F is running both legs of the relay race. So we've got F. Remember, F is this function here. Remove the variables and replace them with -5. I'll just do that with mental math. -5 squared plus -5. That's 25 plus -5, which is 20. You could try to fit all this calculation inside of these parentheses if you want. I usually use the margin of my paper, or if it's small enough, I'll just do it in my head. All right, now remember, you're not done yet. You just ran all the way to 20, and now you got to pass it off, obviously, to yourself. So take a little breath, and then now plug 20 back into F again. This time I'm just going to write it here because I'm all out of room. There's no reason to use more scratch paper now. So that's 420, 420. Okay. So that's fuffing with a number. I guess we just got to do it, right? I want to make sure it's complete. Let's do some Goggin. GOG. All right, so let's do GOG of 1. So that's G of 1. With these small numbers, and there's no powers, we could do it with our mental math. So what do you get when you plug 1 into here? You get -4. Yeah? 2 times 1 is 2. 2 minus 6 is -4. Now, what do you get when you plug -4 into here? You go back to the mother function. Ooh, I'm starting to use that word. This is the mother function here. So we're going to plug -4 into x. So 2 times -4, that's -8. Yeah? -8 minus 16 is -14. And if you have to do the math, that's okay. That's what math is for. Math wasn't meant to make us suffer. It's meant to alleviate suffering. Right? It's the cure. It's not the disease. Okay. I don't know what else to say except we should just do more of these. I want to broaden our perspective and use some other types of functions. I like to start off with the simple functions, but I don't want to end there. I want to make sure I get into some more complicated functions. What about a constant function? So this is what we call a constant function. All right, this one's not constant. It's what's called linear. This is constant linear. It's also linear, but it's a constant. It's supposed to be a C. It means that the output is always 5. Or whatever number is given in your constant function. In mine, it's 5. Yours could be 2 or 3 or -1 or 0 or some other constant number. No matter what, it's always going to be 5. So when we do f of g of -3, we're really just doing f of 5 because g always produces 5. Yeah. It doesn't matter that you're plugging in -3. It's a constant function. You plug in -3, it doesn't matter. So I don't care. I'm just always going to say 5. Yeah. It'd be like having a phone that dialed one particular number. No matter what you type in the phone, it just always dials what it wants to dial. Yeah, it's a constant phone. Yeah. I don't think they make those, but maybe a phone that only calls one number, a hotline or something like that. Now, f is not constant. So you actually have to do f. So it's 4 times 5 minus 1, which is 19. 4 times 5 is 20. 20 minus 1 is 19. Now this one, it's a free answer. Because g is a constant function, it doesn't care what f does. The input doesn't matter because the constant function is outputting always 5. So you could sit there and figure out what f is if you really wanted to waste your time, but it doesn't care because g is going to say, I don't care what you do. I'm always going to give you the same answer, and the answer is 5. Okay. That's a very special case, the constant function. So maybe we'll get more into that later, but I'll put that to rest for now. But that's what I mean by broadening our perspective of the different types of functions that we could have. One of those types is a constant function. I guess I could ask an abstract question. What would happen if both of these functions were constant? And the answer is both of the answers would be free. They would just give you whatever their constant value is, and you wouldn't actually have to do any math at all. I don't think I'm going to do that. That's too easy. But I'll give you one constant function. All right. How about some fraction functions, also known as rational functions? So what about these? Everybody loves fractions, right? I hear that all the time. Dr. Jordan, I love fractions. They're my favorite. I don't have enough room to do two parts on this one, so I'll just do one part, although I will probably show you the other way as well. So this would be fog of these two functions. Now you do have to simplify your answer. So you can't leave your answer in some unsimplified form. So we're going to take the formula for f. All right, so that's f with no parentheses. And then you're going to put g in it. And again, I know I said this earlier, this is the name of g. why don't we just skip that step? I really need to save some space here and put who G actually is. 6 over X. That's actually who G is. Okay, now you want to simplify this. So the trick is to multiply by 1. This is what we call a special form of 1. It's X over X. Now, why am I using X? Because the denominator is X. If the denominator was 2X, well, then I'd do 2X over 2X. If the denominator was X minus 3, then I'd do X minus 3 over X minus 3. Yeah. So I would do whatever the denominator is, it tells me what to do there. And then multiply like this. So now you have 6X over X. You're going to multiply the tops here. And then you have 6X over X minus 7X. Make sure on this one you distribute. So it becomes 6X over X and then 7X. And now cross off any factor that equals 1. So that equals 1. That equals 1. I wouldn't write a 1 because it'll look like 61. It's technically 6 times 1. Just write 6. This is 6 times 1. Over, and then this is also 6 times 1. 6 times 1. And then minus 7x, and that's your final answer. Don't get carried away with the crossing off. If you keep going and cross off those 6's, then that would be incorrect. All right, and that would be a review of basic algebraic rules of sometimes you can cross things off if they are products, but if they are sums or differences, adding or subtracting, then you cannot cross things off. Canceling is really a multiplicative and a division process, not an addition or subtraction process. Okay, example 8. Why don't we go the other way? Go the other way. So we got f of x is 5x plus 9. And g of x is 1 over x minus 3. Let's do goff of x and goff of 1. And let's make it 2. Change my mind. Really doesn't matter. I mean, a number's a number, but I'm trying to move this along. So goff means take the formula for g. Let's just skip that step and go right to it. Take the formula for g. There's the formula for g, and put f inside of it. This is already done. We don't need an LCD. It's just 5x plus 6. Just remove the parentheses, combine the 9 and the 6, and you're done. I was going to say no about something, but it's fine. We're done. In other words, you can't go any further. There's no canceling, no simplifying needed. That's actually nice when that happens. Yeah. All right, so now goff of 2, I do have 2 choices, right? I still have those 2 choices. I could take 2, plug it into f, figure out what I get, and then take that and plug it into g. Let's do that mentally. Okay. Nothing up my sleeve, nothing in my hand. That's why I picked a nice number like 2. 5 times 2 is 10, plus 9 is 19. And now take 19 and plug it into here. 19 minus 3 is 16. So the answer is 1/16. Yeah. Well, I could also just plug 2 into here. Check, you get 1/16 either way. Yeah. I know, it's a tough pill to swallow. I'm teaching you things and I'm going to tell you more than one way to do it. I've gotten an email once that said, Dr. Jordan, I really appreciate your teaching and your great explanations and everything, but why do you give us so many ways to do the same problem? Can't you just give us one way? It'd be a lot easier for us. And I have to reply, well, then I'm not educating you if I do that. I'm actually not doing my job. My job is to educate you. And educating you means to give you all of the options and let you know what all the different ways of doing them. Then it's up to you to decide. That's where the real education happens, is in the decision-making process. Anybody can solve a problem. That doesn't make you educated because you can solve for X, right? What makes you educated is knowing what method you're going to use out of this big, abundant list of methods that you have. Understanding why you're choosing one method over another, right? That's your voice. That's your vote. That's what really matters. Not just doing what I told you to do. That's not your voice, right? I know, I go off on a rant, but I'm home alone on YouTube, so what do you expect me to do? Couple more? A couple more, we'll cut this short, and I'll probably finish this lesson in a part 2. Example 9. I got a feeling these fraction ones are going to be sort of a chore for some folks. So let's go ahead and do a fog. And let's just do it for X. I'll spare you the plugging in the number part. I think I've kind of had enough of that. All right, so we got fog here. Fog, of course, means F of G or F after G. Sometimes they'll say after. And so we're going to take the formula for F. I have a recommendation with negatives. If you see a negative in front of a fraction, put it up in the numerator. Remove the variable, and then put all of G inside of it. So G becomes X. All of this goes inside here where X used to be. All right, now this time we're going to need some simplification here. We're going to need some simplification. So what are we going to do? We're going to multiply by a special form of 1. Now we're going to talk about these are called rational functions. Rational means ratio. Later in the semester, we'll have a whole lesson on rational functions. For today, I'm just teaching you the technique, not really getting into the philosophy too much. But the idea is you're multiplying by 1. Yeah, x plus 4 over x plus 4. It's always going to be whatever the denominator is. Just look for the denominator in your problem and then put it on top of itself. Okay. So we're going to distribute this entire thing like this. So now you've got negative 2 x plus 4 over 1 x plus 4 x plus 4 plus 3 x plus 4 x plus 4. And I want to make a correction really quickly. Since you are multiplying 3 times 1, you can just go ahead and skip it here. 3 times 1 is still just 3. I was going to cross those off, but I don't need to do that. All right. I mean, if you prefer, I could have done that. I could have gone, you know, x plus 4, x plus 4, and then crossed them off. But either way, you're still going to get just 3. So I just wanted to say that right away. The 3 is just going to stay a 3. Here is where all the work is going to happen. You got x plus 4, x plus 4. The denominator is now 1. So you get negative 2x minus 8. All right? And then the denominator is just 1. If the denominator is 1, you can ignore it. All right, you probably remember that from basic math. Every thing, every symbol, every number, every equation has an invisible 1 underneath it. So you can just ignore that. It's gone. And so now you have negative 2x minus 8 and then plus 3. So the final answer is negative 2x minus 5. And that's your final result. If you are asked to plug in a number, like a 0 or a negative 2 or a 3 or something like that, you can either do it now. I would just do it now that you've done all the work. Or you can go back to the beginning and plug it in. It's up to you. I recommend trying it both ways. Okay, I got to run to my office hours. I'll be on Zoom. I don't know what time you're watching this video, but I'm on Zoom every day, Monday through Thursday, 11 o'clock. Check on Canvas if you need the link or email me. I'll be happy to send it to you. Until we meet again, this is Dr. Jordan reminding you, I will see you on the internet. Bye-bye.